This video will generate the trendline and polynomial of the Euler sine function using the Taylor series expansion and the IMEXP function. We begin with the values of f. So data validation, list of items from 0.44 to 1.6. So we can start with 0.44. And we continue with the Taylor series expansion, which is the summation of a times x to the power n, where n starts from 0 to infinity. And the value of a is equal to array formula sine. That's sine n pi f. So n times pi times f. That's the numerator, divided by factorial n. And now we can complete the expansion. So array formula, series sum of the x values raised to the power n, where n starts from 0 incremented by 1. And the coefficient a will be this range. Now we can complete the im-exponent function, which is the imaginary part of the Euler's raised to the complex number. And the complex number is x cosine pi f plus ix cosine or sine pi f. So begin with the complex number. Array formula. Complex. That is, the first part is x cosine pi f. So x times cosine pi times f. And close the cosine. So x cosine pi f plus ix. So instead of ix, you put comma. Now x sine pi f. So x times sine pi times f. And close the parenthesis. And enter. Now that we have completed the Euler's, we extract the imaginary part. So we have not completed. So it is raised to the power e. So we use IMEXP. So IMEXP. So Euler's. So this is the complex number raised to the power the complex number. Then enter. Now we can get the imaginary part. So the imaginary part is imaginary. So imaginary. And we'll chart this. Insert chart. And we use scatter chart. Column is labeled. And show the trend line. Under series, show the trend line. The type, polynomial. The degree, 6. For the label, use the equation. We don't need a title. We need a space. So here's our trend line and polynomial of the sine function. We can change the value of f to 0.5. So the blue one is this one. It's a sine function. We change this also to 0.5. Now they are the same. It's a steady state sine function. Change the value of the expansion f to 0.58. So this is now decaying. We'll also change this to 0.58. Now it's decaying. Change this to 1.4. So this is now the value of f. We change it to 1.4. Now they're the same. So it's decaying. We continue. We change this to 0.5. It's a steady state. We change this to 0.5. Change this to 1.6. Now it's expanding. Change this to 1.6. So this completes the use of the Taylor series sum function and the IMEXP function to generate the Euler's sine function.